Greetings and welcome to Unit 8 Opener number 5, where we'll be solving a system of equations by graphing. So both of these equations are in slope-intercept form, so they should be pretty quick and easy to graph. I'll do the first one using a blue line. So let's see, 3x minus 7, so I'm going to start at negative 7. And then the slope is 3, so that means up 3 over 1, up 3 over 1, up 3 over 1, and I don't know how far I need to go in order to find the intersection here. So I guess I'm just going to keep going for a minute and make sure I cover it. Now remember, if the slope is positive 3, that means you can also go down 3 and to the left 1. And that's because negative 3 divided by negative 1 still gives you a positive 3. Okay, so let's call this good enough with the blue line. That's the first line, and I will do my best to draw something approaching a straight line through those points. Alright, next up I'll graph the second line in red. This one is y equals 8 minus 2x, so it has a y-intercept of 8 and a slope of negative 2. So that'll be down 2 over 1, down 2 over 1, down 2 over 1. You'll notice the two lines intersect at that point. Down 2 over 1, down 2 over 1. Since I really only care where these things intersect, I don't see any reason to draw the red line any further than that. So I found the solution. I can write the solution. The solution to this system of equations is that point right there, 3, 2. X is equal to 3, y is equal to 2. Real quick, we can just check and make sure that solution really works. And remember, in order to be a solution to a system, it has to make both of the equations true. So let's see, if I do 3, and then I'm going to substitute in a 3 for x, minus 7. 3 times 3 is 9, minus 7 is 2. So that checks out. It works in the first equation. Let's check the second equation. 8 minus 2 times 3. So that's 8 minus 6, which is again 2. It checks out in the second equation. So that really is the solution. It's the one point that makes both equations true. And while we're at it, why don't we go ahead and classify this system? Now it does have a solution. It has one or more solutions, which means that the system is consistent. And since these two lines aren't the exact same thing, we also know that it is independent. So anytime you have a system that is consistent, let me say that a little more carefully. Anytime you have a linear system of two equations, and it is consistent and independent, that means you will have two lines and they will intersect in one place. And that's what it looks like to be a consistent and independent system of two linear equations.